Hi guys, in this specific video we're going to see the relationship between a Pythagorean identity and the unit circle. Now we had mentioned the concept of a unit circle as a circle which has a stretch of a radius of 1. Therefore we are going to consider the case for this specific illustration as one of a unit circle. Now we had said that an extension of an angle for this initial and terminal side is going to be given as theta. And if we try to draw this specific right triangle in this particular case, it's going to assist us find the relationship that exists between this unit circle and the trigonometric ratios and this specific angle that has been subtended at this specific center. So therefore, we said that there's a relationship that exists between these opposite sides of this angle and the adjacent one. And this is going to give us what we refer to as trigonometric ratios for the sine, the cosine, and the tan of theta. And of course, they are inverse, which are regarded to as a cosec, sec, and cotangent of theta respectively. So in this case, if you try to look at this, we have given a notation for the opposite of this angle as y and the x-axis respectively. So therefore, if you try to analyze this using the various ratios that we have for the different trigonometric functions for the sine, cosine, and tan of theta, we're going to see that there's a specific relationship that is going to exist between the sine and the cosine of theta, and this is going to be given by the tan of theta. So therefore, in a sense, if we have a ratio between the sine of theta and the cosine of theta, that is going to give us the tan of theta. And this particular relationship is going to be displayed whenever we are going to compare these inverse functions of the three basic trigonometric ratios for the sine, cosine, and tan of theta. And therefore, these are going to assist us to derive what we refer to as the equation of a circle, which has been given in this specific case or in this specific form given as such. So if we try to look at this, we can be able to analyze that using this specific case, whereby we're going to have the cosine of theta represented as the opposite, or rather, which is going to be given as adjacent over the hypotenuse, x over r. So therefore, the sine of theta as well is going to be given as opposite over the hypotenuse, which is y over r, given as such. So having these two ratios, then therefore, we are going to compare a case whereby we can be able to square these specific sides. And we had said that from our trigonometric identity, we can have an identity whose square of the cosine and the sine of theta is equivalent to unity. Therefore, if we square these specific two ratios, we are going to achieve this specific identity that we refer to as a trigonometric identity, given as the square of the sine of theta and the square of the cosine of theta equivalent to 1. Now, the other derivatives that I've mentioned for cot, sec, and the cosec over theta can be able to be obtained, other variant forms can be able to be obtained from this particular identity that I've given as such. So therefore, this is referred to as a Pythagorean identity, and this is in comparison, or rather in relation to the relationship that exists between theta and the ratios of the sides of these squares, or rather this right triangle that I've mentioned in this specific case. Now this for the cot and the cosec of theta, the relationship can be achieved by dividing both sides by the square of the sine of theta, and this is going to give us a ratio that is going to represent the cosec of theta given as such by dividing by sine. So this is going to give us an identity that is the cot, the square of the cot of theta plus 1 is equals to the square of the cosec of theta. And if we divide both sides by the cosine of theta, then therefore that's going to give us the square of the tan of theta plus 1, which is equivalent to the sec of theta. So the relationship that exists between this unit circle and the various aspects of this triangle that exists is going to assist us evaluate and do some of the trigonometric ratios and identities. And this is going to be handy, especially in trying to do some aspects of geometry that we're going to come across. So catch us in our other videos where we're going to look at these specific relationships and try to see how we can be able to maneuver around these various concepts and try to create relationships between various concepts, especially in topics related to the concept of geometry. So that is it for now, guys. Bye, God bless.